All right, getting started here. Looks like we're live. This is going to be the homework help video for simplifying radicals with multiple variables. This is just going to be some more good practice of just simplifying radicals. We're adding another variable, but we'll practice all of our techniques here. Getting started with number one. Here, let me get rid of number three so I got a little more space to work with. For number one, I'll do kind of the longer method, which I've been calling our jailbreak metaphor. Let me zoom that a little bit more too. Here we go, number one. So in the jailbreak metaphor, I need to do the prime factorization of whatever the numerical part is. 72, for example, can be split into 9 times 4. 9 can be split into 3 times 3. 8 can be split into 4 times 2. And 4 can be split into 2 times 2. Now all of these numbers are prime, so we're done. And then I'm going to rewrite the whole radical. But when I do that, I'm going to write the prime factorization of the numerical part, so 3 times 3 times 2 times 2 times 2. And I'm going to expand out all of those variables all the way. So x to the fourth becomes x times x times x times x. Y to the third becomes y times itself 3 times. Now to leave, the rule is if it's a square root, you need to leave in groups of 2. Likewise, if it's a cubed root, you need to leave in groups of 3. So let me group together as many groups of 2 of identical things as I can. And the reason I can do this is now I could express this 3 times 3 is 3 squared. The square cancels the square root, and a 3 emerges. So when these come out, I've got a 3 times 2 times x times x times y. So one copy for each pair. And then left behind is a 2y. And then this brings us to our final answer of 6x squared y root 2y. All right, for number two, let me do number two with the quicker method, which is to look for the biggest perfect squares and to take those out individually. So what I'm going to do with number two is I'm going to factor this. I might refer to a list of perfect squares to figure out what's the biggest one that will fit into 125. That number is 25, leaving a 6 behind, and then I'm going to break the u to the third into a u squared and a u, and the v to the fourth, I'm going to break that into a v squared and a v squared. So there's 3 u's. There's still 3 u's here. I've just grouped 2 of them together, left 1 behind. All right, now I'm going to distribute the radical. Square root of 25, square root of 6, square root of u squared, square root of u, square root of v squared, square root of v squared. The square root of 25 is just 5. And then these square roots negate the squares. And I've got 5 root 6 root u times v times v. I'm going to put these back together under 1 square root and regroup this so that everything not in a square root comes to the front. For a final answer, 5v squared root 6u. Check if that's right. 5v squared u root 5u. Oh, yes. I've made a little mistake here. 125 is not 25 times 6. It's 25 times 5. So let me replace all these 6's with 5's. Even teachers make mistakes. Should be the lesson here. But didn't change our final answer that much. All right. Next, we'll do number 5. So number 5 is interesting because it's got a cubed root and we've got a negative inside of the radicand. The radicand is negative. And if this was a square root problem, we would just have to say no solution because you can't take the square root of a negative. But you can take the cubed root of a negative. So we can take the cubed root of a negative. Just want to write that. It's an important thing to note. And that's because cubed roots ask the question, what value cubed equals this number? Well, it's okay to take the cubed root of a negative number because a negative number cubed will be negative. Negative number times itself 3 times will always be negative. So here, let me do this with the slightly faster method. I just want to look for the largest perfect cube that fits into 448. So let's start. 4 cubed is 64. Does that fit into 448? It does 7 times. All right, I've got a good feeling that that is the correct way to break this up. But when I do this, when I break the negative 448 into 2 factors, one being a perfect cube, I want to make the perfect cube the one that's negative. So when I factor this, the 448, I want to make it a negative 64 times 7 equals 448 times x, why don't I split it up now, x to the third, x x squared, and a y. All right, so there's still 8 x's there. I've just broken them up into different sized groups. All right, let's split this up. I want the cubed root of negative 64 by itself times, let me put all these cubed roots of x cubes to the front. And then everything that remaining, I'm just going to leave under one big cubed root. So there's still the 7, there's still an x squared, and there's still a y. That's just going to be the way that's going to look in the final problem. These can be simplified. The cubed root of negative 64 is negative 4. All right, if you're not sure about that, you can try it in your calculator. To get a cubed root, you have to hit the math button. Cubed root is option number 4. So I'm taking the cubed root of negative 64. I get a negative 4. And that's because negative 4 times negative 4 times negative 4 equals negative 64. All right, we got some power negation that happens. And we're left with x times x times the cubed root, 7x squared y. This becomes negative 4 x squared cubed root 7x x squared y. And that right there is our final answer. All right. Let's see if there's another one that's unique. That same technique should work fine for those problems. We should be able to handle 9 and 10 pretty easily. Let's just do one of these examples here, and we'll call it a day. Which one looks to be more challenging? Both pretty similar, I guess number 12. So for number 12, I want to simplify those radicals as much as I can. So I'm going to split that 54. Let's do it with the jailbreak method since we didn't do that for the last one. Take the 54, let's do the prime factors. I can split that into a 2 and a 27. The 27 I can split into a 3 and 9. The 9 I can split into a 3 and 3. So 3 root 57 is the same as 3 root 2 times 3 times 3 times 3. I can make one group of 3's and take them out, multiply them to the front, and what's left behind, we'll just put those back together, the 2 and the 3. And so this becomes 3 times 3 times the square root. 2 times 3 is 6. Simplifies that to 9 root 6 for that. This is just the same thing again, minus 9 root 6. So those two terms are just going to cancel each other out. Let's see, the 12, why don't I split that up into a square root of 4 times the square root of 3. Makes this a 3 times 2 times root 3. Makes this a 6 root 3. And the 24, I'm going to split that into 4 times 6. Square root of 4, square root of 6, make that 2 root 6. Keep the minus there. Minus 2 root 6. And then that's just our final answer. Those can't be combined any further because they don't have the same radical, so they're not like terms. It's very similar to being like terms when we're combining radicals. Let's see if I got number 12 right. 3 root 6 minus 2 root 6 root 3 minus 2 root 6. 6 root 3 minus 2 root 6. All right, very good. All right, so we'll call that good for this video. Hopefully this helps. And I will see you in class later on.